Okay, everybody. This is our last video of the day on the multiple angle identities and formulas, and we're going to do just a couple of problems involving the double angle formulas. Let's just recap, re-look at them so we know what they are. This has the double and half angle identity or formulas in it. I've shown it before, and before we used the half angle identities to answer the previous questions. Now we're going to be using the double angle formulas, these ones down here. And what they say is if you have an angle alpha and you know sine of alpha and cosine of alpha, then you can use those, combine them to find sine of 2 alpha. The double the angle. So same for cosine of 2 alpha, same for tangent of 2 alpha. And just like above, some of them are simpler than others, the formulas, and some for cosine, in this case, there's a bunch of different alternative versions that are all the same, that are all equal. Okay. Let's go ahead. We'll come back and refer to these when we dive into them. So let's look at this is example 18.7. Find the trig functions of the angle 2 alpha when alpha has the property below. So this is asking us to find the trig functions of the angle 2 alpha when the following conditions are satisfied. The sine of the angle alpha is 3/5. Now, what's interesting is that they never tell us what the angle alpha is. Okay, and alpha is in quadrant 2. Okay, where to begin? Well, here's what we can do. First of all, for alpha in quadrant 2, let's just think about what that tells us. This is quadrant 1, 2, 3, 4. For angles in quadrant 2, cosine is like x, cosine is negative on the left, and sine y is positive. So cosine is negative, sine is positive. And tangent is sine over cosine, and that's going to be a positive over negative. Tangent is going to be negative also. Okay. So maybe we just make a little note here. Sine is plus positive, cosine is negative, tangent is negative in quadrant 2. The other basic fact that we're going to use here is the fact that for any angle alpha, sine squared alpha plus cosine squared alpha equals 1. So here we have that sine squared alpha plus cosine squared alpha is equal to 1. Now, an aside about one of the more annoying notational things in mathematics, when we write this sine squared alpha, this doesn't really make a lot of sense because the squared is really being attached to the output of the sine function. That is, if I give you an angle alpha, what this is telling you to do is plug the alpha into sine, get the answer, and then square it. So what it really should look like is the following. It should look like sine of alpha, whole thing, squared. Okay, and similarly, cosine squared alpha really means cosine of alpha, whole thing, squared. So if it helps you to think about this and this form, this is really what it means. The squared is applying to the entire thing, the sine of alpha altogether, not just somehow to the sine without the alpha. Without the alpha, sine doesn't make sense by itself. It doesn't have anything to plug into it. Okay, so end of our aside. Sine squared alpha plus cosine squared alpha equals 1. We happen to know sine of alpha is 3/5. And because of that, if we fill it in, then there'll just be left in this formula cosine squared of alpha, and that's we can somehow solve this thing and get cosine of alpha by itself. Let's see how it works. The first thing I'm going to do is just rewrite sine squared and cosine squared the way that we did over here because it's much easier for my brain to work with them that way. So this really means sine of alpha squared plus cosine of alpha squared is equal to 1. Now, we know we're given in this problem that the sine of our angle, we don't know what the angle is. We know it's in quadrant 2, but what we do know is that its sine is equal to 3/5. Okay, so let's go ahead and plug that in here. Sine of alpha is 3/5. So this is 3/5 squared plus cosine of alpha squared is equal to 1. Now, this we can simplify. The 3 over 5 squared, we can square the top and square the bottom. That gets you 9 over 25 plus cosine of alpha squared is equal to 1. And I'm going to try to find cosine of alpha. We know sine of alpha, and if we can find sine, cosine, and tangent of alpha, then we should be able to use those with the double angle identities to find sine 2 alpha, cosine 2 alpha, and tangent 2 alpha. So let's go ahead and solve this thing for cosine alpha. That's what we're after. Okay. How am I going to do it? Well, first let's move that 9 over 25 over. I'm going to subtract 9 over 25 on both sides. On the left-hand side, it's nice because those cancel. On the right-hand side, well, let me see. What do we have? Left-hand side still has cosine of alpha, whole thing squared, and then now that's equal to 1 minus 9 over 25. Okay. So far, so good. I'm going to simplify the right-hand side by combining them into a single fraction. I'm going to need to get a common denominator, which means I'm going to use the denominator of 25. So I'm going to multiply that 1 by 25 on the top and bottom. So this is cosine of alpha squared is equal to 25 over 25 minus 9 over 25, and then combining into a single fraction, this is 25 minus 9 over 25. That's cosine of alpha squared. Subtracting on the right, 25 minus 9 is 16 over 25, and that's equal to cosine of alpha squared. And now to get that cosine of alpha by itself, I'm going to take the square root. That's what will cancel off the squared. But beware, when I take a square root on both sides, to cancel off a squared, I must put a plus or minus on the right-hand side because fundamentally it's because every positive number has 2 square roots, a positive one and a negative one. Okay. On the left-hand side, we're just left with cosine alpha. And on the right-hand side, we have plus or minus radical 16 over 25. We can split that up into radical 16 over radical 25. And both of those have nice radicals, so this is equal to plus or minus 4 over 5. Now, which one is it? Positive 4 over 5 or negative 4 over 5? That's when we need to go back to look at the quadrant. We said this is in the second quadrant. That was what the problem said. And in the second quadrant, sine is positive, cosine is negative, and tangent is negative. So if cosine is equal to either positive or negative 4 over 5, in this case, in the second quadrant, it must be the negative one. So equals negative 4 over 5. That's our answer for the cosine of alpha. Cosine of alpha is negative 4 over 5. Sine of alpha, that was given to us. That was positive 3 over 5. And we've almost found all the trig functions, at least the 3 basic ones, sine, cosine, and tangent, for the original alpha. If you want, you can find tangent of alpha, which is sine over cosine. Sine alpha over cosine alpha. And let me see, that's going to be 3 over 5 divided by minus 4 over 5. Now, a fraction on top of a fraction, we're going to want to be able to bring that up to the top and flip it over. So that one is, it's going to be equal to that 3 over 5 that was there already, times, if we flip it over, it's going to become 5 over 4, and it's still negative. That negative follows along with it. What do? We have 3/5 times negative 5 over 4. The 5s cancel. And we're just left with a negative times a positive. That's negative, and 3 over 4. That is our tangent of alpha. So we now know sine of alpha, tangent of alpha, and cosine of alpha. Okay, let's go ahead and look at our formulas. Now, the example says, find the trig functions of 2 alpha. So the trig functions, let's find at least sine, cosine, and tangent. And we're going to need the double angle formulas, and those are given to us here. I'm going to go ahead and take a copy of them down below for us to look at. Okay, so to reach the end of this problem, part A, we need to find sine, cosine, and tangent of 2 alpha. It said find the trig functions of 2 alpha. And we're going to do it based on the sine, cosine, and tangent of the original alpha. Cosine of alpha was negative 4 over 5, sine of alpha was 3 over 5, and tangent of alpha was negative 3 over 4. Let's go ahead and plug in and see what we get. So, sine of 2 alpha is equal to 2 times the sine of alpha times the cosine of alpha. Well, the sine of alpha, 2 times the sine of alpha was 3 over 5, cosine of alpha was negative 4 over 5. And here we can multiply across the tops, multiply across the bottoms. 2 times 3 is 6, 6 times 4 is 24, and that's a positive times a negative. It all comes out to be negative 24, divided by, and 5 times 5 is 25. So we have negative 24 over 25. That is sine of 2 alpha. Cosine of 2 alpha? Well, that one's equal to cosine squared alpha. I just always would prefer to write that as cosine alpha, that whole thing squared. That's what it means. Minus sine of alpha squared. Of course, there's a couple of other different formulas we could use. I'm going to use this one, but they are equivalent. They'll give you the same answer. The cosine of alpha was negative 4 over 5. And that's squared. And sine of alpha was 3 over 5. That's squared, and that just comes from our recording of the cosine, sine, and tangent of alpha. I'm just using the cosine and sine here. Okay. Let's simplify this. Negative 4 over 5, when we square it, we square the top and square the bottom, and it's a negative, but when we square it, that negative becomes positive, so it's 16 over 25. Minus, and here similarly we square the top and bottom. Here the minus sign in the middle is not underneath the squared, which means the minus sign stays. It doesn't disappear because we're only squaring the 3 and the 5. So squaring the 3 gets you 9, squaring the 5 gets you 25. It's 16 over 25 minus 9 over 25. We can combine those together. 16 minus 9 over 25. And that is equal to, let's see, 7 over 25. So that is our cosine of 2 alpha. And then finally, tangent of 2 alpha. Here's our formula. You can just see it at the top of the page here. It's 2 times tangent alpha over 1 minus tangent squared alpha. And that tangent squared alpha, that's really tangent of alpha squared is the way I would prefer to write it. So let's go ahead, we'll copy it down. It's 2 tangent alpha over 1 minus tangent alpha whole thing squared. Now, what was tangent of alpha? We found that up above. It was negative 3 over 4. So let's go ahead and substitute that in. This is 2 times negative 3 over 4 over 1 minus negative 3 over 4 squared. What am I going to do here? Well, I'm going to, on the top, I'm going to multiply 2 times the parentheses. The 2 is going to cancel, and the negative 3/4 is going to cancel with the 4 on the bottom. This guy cancels here and leaves just a 2 on the bottom. And so on the top of this fraction, there's the big fraction, and on the top, we have negative 3 over 2. On the bottom, it's 1 minus negative 3/4 squared. The negative times the negative is going to cancel when we square it, but there's still a negative there from the middle, so I'm going to leave that negative there. This negative disappears when we square, and when we square the top and square the bottom, we're going to get 9 over 16. All right, so we have a few things that we need to take care of here. There's a bunch of different ways to simplify this. One way, certainly, is to combine together the things on the bottom into a single fraction. So this 1 minus 9 over 16, we're going to put that into a single fraction. And to get a common denominator for that, I'm going to multiply the 1 times 16 over 16 times. So, leaving the top of this big fraction alone, on the bottom we have 16 over 16 minus 9 over 16. Combining the bottom together, this is minus 3 over 2 over, and 16 minus 9 over 16 is 7 over 16. Now we have this is still messy, but it's looking a little better. We now have a fraction divided by a fraction, and we can simplify this by bringing this up to the top and flipping it over. So that's going to look like negative 3 over 2 times, when we flip it over, we get 16 over 7. We can multiply these. I notice that there's something I can cancel here. Since they're multiplied, I can cancel 2 on the bottom with the 16 that leaves behind an 8 up there. Altogether, let's see, 3 times 8 is 24, and on the bottom is 7. Oh, and there was a negative in front of the whole thing. Let's not lose that. Negative 24 over 7. So altogether, this is our answers for part A. Let's just collect our final answers here. This is the answer to part A. Sine of 2 alpha, I'll just go collect them for my work up above. It was negative 24 over 25. Cosine of 2 alpha, that one was 7 over 25. And tangent of 2 alpha, that was equal to negative 24 over 7. If you were paying close attention here, you might have noticed that there was a simpler way to get that final answer, the tangent of 2 alpha. We also know that tangent is equal to sine divided by cosine. So once we had found sine of 2 alpha and cosine of 2 alpha, we could find tangent of 2 alpha just by taking this sine of 2 alpha divided by cosine of 2 alpha, and it would have been much simpler to flip the bottom one up to the top and cancel. We would have gotten to the same answer in fewer steps. So whether you wanted to use the double angle formula or whether you saw that you could do it that way, either way is fine with me, provided you got this answer. This is our answer to part A. These are the trig functions, 3 of the trig functions, sine, cosine, and tangent of this angle 2 alpha. Now, of course, there are 3 other trig functions, rather, secant, cosecant, and cotangent. However, generally, if someone says find the trig functions of, usually you can get away with 3 of them. I will specify if I ever want you to give me more than just 3 of them. Okay. So, let's take a look at the next one. This is going to be our final example of this lesson. Then it's going to be up to you guys to go ahead and work on the web work. Okay. We want to know, this is example 18.7b, find the trig functions of 2 alpha when we know that tangent of alpha is 12 over 5, and alpha is in quadrant 3. Let's go ahead and see what we can do with that. Okay. So, this is part B. Tangent of alpha is 12 over 5, and alpha is in quadrant 3. Now, just as a reminder, here's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In quadrant 3, both the x and the y are negative over here. That means that the x is like cosine is negative, the y is like sine, sine is negative, cosine and sine are both negative, but tangent is positive. So for alpha, we have that cosine is negative, sine is negative, but tangent is positive. Okay. And you'll see that the tangent that is given to us, tangent of alpha, is 12 over 5. So that matches our expectation here. Great. Let's go ahead and calculate. One of the many trig identities that you guys may or may not remember, there are some trig identities I expect everyone to remember, like sine squared plus cosine squared equal 1. But there's a similar one that involves tangent squared, and if you don't remember it, I'm going to show you, I'll tell you what it is. So this is a recall. What is a trig identity involving tangent that's similar to sine squared plus cosine squared? Well, if we take sine squared alpha plus cosine squared alpha equal 1, and if we want to get a tangent, tangent is sine over cosine. So what I'm going to do is just divide everything here by cosine squared alpha. Look, you'll see at the end of this that we just get another trig identity, and if it's one that you know already, that's fine. But this is, if you don't know it, this is how I remember it. So sine squared over cosine squared is tangent squared. Cosine squared over cosine squared just cancels and is 1. And 1 over cosine squared, well, 1 over cosine is that other trig function secant. So this one is secant squared alpha. And just as a reminder, secant alpha is 1 over cosine alpha. Okay. How does this help us? Well, we know tangent of alpha, so we can substitute tangent of alpha into this guy, and then that will allow us to find secant. Once we know secant, we can put it in here and find cosine. Once we know cosine, we can use sine squared plus cosine squared equals 1 and find sine. So that's our strategy for finding the sine. We know tangent for finding the sine and cosine. Here we go. So the first thing we're going to do is find secant. And we're going to do it using this starred equation. And I'm just going to rewrite it. Instead of tangent squared alpha, it's really tangent of alpha whole thing squared plus 1. And that's equal to secant of alpha whole thing squared. Tangent of alpha, we know it's given to us at the top. It was 12 over 5. So this is 12 over 5 squared plus 1 is equal to secant of alpha squared. 12 over 5 squared, well, we square the top and square the bottom. 12 squared is 144. 5 squared is 25. And then plus 1 is equal to secant of alpha squared. On the left-hand side, we can combine these by getting a common denominator of 25. We're going to multiply that 1 by 25 over 25. So we have 144 over 25 plus 25 over 25 is equal to secant alpha squared. Now, combining together, on the left, we have over 25, 144 plus 25. This is the kind of math problems. This is a little bit less advanced than what my 7-year-old daughter is doing right now. She's doing 3 digits plus 3 digits. Anyway, strategize your way through it. 144 plus 25 is going to come up to 169. 169 over, and that denominator is still 25. Now, 169, that may or may not be a familiar number to you, but I just happen to stick in my head 169 is 13 squared. That's just a nice thing to know about it. Just like 144 is equal to 12 squared. That's just an aside. This is getting friendly with your numbers in ways that will help you when you're doing these problems. Okay. And this is all equal to the secant of alpha squared. Now, we want to get secant of alpha by itself, so we're going to take the square root of both sides. And don't forget, when we use a square root to cancel off a squared, on the other side we have to put a plus or minus. So on the right-hand side, they cancel and just give us secant of alpha. And on the left-hand side, we have plus or minus. Radical 169 over 25, we can split that up into the radical of the top over the radical of the bottom. And as we just noted, the radical of 169 is 13. So this is plus or minus 13 over 5. That's equal to secant. Now, we still have to decide if it's plus or minus, but I'm just going to do one more thing, which is I'm going to remember that this guy, secant, is equal to 1 over cosine. And so this thing right here, the 13 over 5, is 1 over cosine. Secant, I'm just going to replace that secant alpha with 1 over cosine alpha. And that's 13 over 5. Okay. What's nice about a fraction equal a fraction is that you can manipulate the two sides in whatever ways you want, as long as you do it to both of them, and the thing will still be an equation. And so what I'm going to do is just flip over both sides, flip this side and flip this side, and when we do so, we get 5 over 13 is equal to cosine of alpha over 1. It's still plus or minus over here. We haven't sorted that out. But the nice thing is that on the right-hand side, cosine alpha over 1, that's just cosine alpha. Cosine alpha is either positive 5 over 13 or negative 5 over 13. To figure out which it is, we look at the quadrant. We said before that this was in quadrant 3, and in quadrant 3, cosine is negative. So down here, cosine is the negative 1. Great. That means that we want to choose this one. And so we have that cosine of alpha is equal to negative 5 over 13. All right. We're doing well. We found cosine, and we know tangent. That was given to us at the beginning. Now it's just a matter of finding sine. There's several different ways that we can do this, but for example, we could substitute into sine squared plus cosine squared equals 1. That would work just fine, but I'm going to do something different. I'm going to use the fact that tangent is equal to sine over cosine. This is another of these trig identities. This is like the basic equations that are just true for trig functions, and it's one of the basic ones that connects tangent to sine and cosine. And the nice thing about this is that we happen to know what cosine of alpha is. It's negative 5 over 13. And we also know what tangent of alpha is. That was given to us at the beginning. The tangent of alpha was 12 over 5. So let's go ahead and put those two numbers into this thing where we see them. Tangent of alpha, that was 12 over 5. That's equal to sine of alpha over, cosine of alpha is negative 5 over 13. Okay. We can move this thing up to the top if we flip it over. So we have 12 over 5 is equal to sine of alpha times, it stays negative, but it flips over. We take the reciprocal, 13 over 5. And we're trying to get the sine of alpha. We want to know what sine of alpha is equal to, so we just have to get rid of this negative 13 over 5. And you can think of doing this in a variety of different ways. We want to move it to the other side by dividing or multiplying. You can divide by the fraction 13 over 5, or you can multiply by 5 over 13 times 5 over 13. And actually, since it's negative, I'm going to multiply by negative 5 over 13, and that will cancel off the negative, it will cancel off the 5, and it will cancel off the 13 in one go. Oops. Okay, on the left-hand side, we can multiply. Let's see, the 5's cancel here and here, and all we're left with is negative 12 over 13. That is sine of alpha. Okay, so collecting, we have sine of alpha, negative 12 over 13, cosine of alpha, negative 5 over 13, and tangent of alpha, 12 over 5. Let's just record those all together in a nice table. Sine of alpha, negative 12 over 13, cosine of alpha, that one is negative 5 over 13, and tangent of alpha is positive 12 over 5. So, are we done? Unfortunately, no, because this problem is asking us to find the sine, cosine, and tangent of 2 alpha, not alpha. And to do that, we're going to need to use the double angle identities. Let's just go back up and grab them again. Here we go. Okay. Here are our double angle identities. Okay. So, with these in hand, and with the values of sine, cosine, and tangent of alpha, we can easily find the values of sine, cosine, and tangent of 2 alpha. Whew, excuse me, it's getting a little bit late here. We got to wrap this up. We're almost done. We're on the home stretch now, so stick with me. Excellent. Here we go. Let's find sine of 2 alpha first. Sine of 2 alpha. Well, it's 2 times the sine of alpha times the cosine of alpha, which is 2 times sine of alpha was negative 12 over 13 times cosine of alpha was negative 5 over 13. And let's see, what can I do here? Well, I notice there's a negative times a negative. Those will cancel each other out. And on the top, we're going to have 2 times 12 times 5, which is 120. And on the bottom, 13 times 13, I happen to know that's equal to 169. So that is my sine of 2 alpha. Now let's take a look at cosine of 2 alpha. Well, this one is either cosine squared minus sine squared, or it's 1 minus 2 sine squared, or it's 2 cosine squared minus 1. There's 3 different versions. Let's use a different one this time. Let's use this one, 1 minus 2 sine squared alpha. Why that one? Why not? Just to give us a little bit of practice using an alternative. So 1 minus 2 times sine squared alpha really means sine of alpha, whole thing squared. And the sine of alpha, we found already, sine of alpha is negative 12 over 13. So this is 1 minus 2 times negative 12 over 13. That's times negative 12 over 13 squared, because it's sine of alpha squared. So that's 1 minus 2 times, the negative times a negative is going to make it positive. 12 times 12 is 144, and on the bottom, 13 times 13 is 169. So this is 1. I can multiply the 2 times this fraction. The 2 goes on the top. Think of that as 2 over 1. So 2 times 144, this is going to be 1 minus 288 over 169. And then getting a common denominator of 169, if we multiply that 1 by 169 over 169, fine, we're going to get 169 over 169 minus 288 over 169. And now we just have to do a little subtraction. We have a common denominator, so the bottom is going to be 169. And on the top, we have to do 169 minus 288. This is what I consider to be a hard arithmetic problem. Go ahead, think it through yourself, use a calculator, write it down, figure out how you can do it. I'm going to do it like this, 169 to 269, that's 100, and then from 69 to 79 is 10, and from 79 to 88 is 9. So I think it's 119, and since the 288 is negative, I think it's negative 119. Could I be wrong? Certainly. All right, let's see cosine of 2 alpha, negative 119 over 169. And then lastly, for tangent of 2 alpha, we could do the double angle identity that's listed here using tangent of alpha, which is 12 over 5, substituting in. But instead, I'm going to learn from my past experience and use the trick that we talked about last time. This is sine of 2 alpha over cosine of 2 alpha. And those are both things that we learned. Sine of 2 alpha was just up here. It was 120 over 169. So the top here is 120 over 169. And the bottom is cosine 2 alpha, which is negative 119 over 169. This kind of looks like a horrible mess, but all we need to do is flip the bottom up to the top, flip it over. So this becomes 120 over 169 times negative 169 over 119. And what's nice is, remember that's a times there, if it helps you to put that in parentheses. The 169s cancel, one on the top and one on the bottom, and we're left with a negative answer, and it's 120 over 119. So just combining together, I think we found everything. I just want to collect everything into our final answer. This is for B. Sine of 2 alpha, cosine of 2 alpha, and tangent of 2 alpha. So collecting our answers, sine of 2 alpha was 120 over 169. Cosine of 2 alpha was negative 119 over 169. And tangent of 2 alpha is negative 120 over 119. Those are our final answers for part B, the trig functions of 2 alpha for this alpha where the tangent of alpha was 12 over 5 and alpha was in the third quadrant. Okay, that's it. Give your homework a try, and I wish you the best of luck. Bye-bye.